between DevOps also. Okay, and initially the same journey started with Redis as a caching. In some previous company later, I got interest into exploring more about this, so got into the community. So this is how the journey started, and this is our fourth meetup in Mumbai. And obviously the event is sponsored by Redis Labs, and thanks to Network for venue sponsor. So let's start with this. See, Redis Streams. Redis you have heard of as in caching only. Most of you must be using it as a caching, but it is beyond cache. So Redis Stream is a path you can explore more beyond the caching. So let's start. So this is the agenda of. So what you can catch up is we can. How many of you are new to Redis here?
I just started.
Okay. So it would be good to explore about the Redis basic first. We'll see the basic about the Redis, then we'll explore the what is the stream. Also the data structure part of Redis. Beyond that, it is a complex data structure actually you can say, but it's quite simple to use. Then we'll see a few commands to explore Redis stream, the use cases you can apply the Redis stream, and finally see the Redis University and certification which is offered by Redis Lab as a free of cost. Okay, let's start with the Redis basics. Okay, see Redis. This is an open source platform. Also, you can say it is available at Redis Enterprise also, but that is you can explore if you are having a project in exploring open source, go for open source. If you have a complexity or beyond that, you can try out the enterprise version also. But all the features are available in Redis open source also. It's in memory, key value stored. It's amazingly fast, extremely fast. If you compare it, the benchmark is available on internet provided by Google and Amazon. The latency, it is considered, the Amazon says it's a sub-millisecond latency, fastest database in the world for caching and storage. Also, you can have it as a database, you can have it as a messaging queuing broker, and beyond that, use cases we will explore in upcoming slides. Okay. The main feature, it actually has a data structure. See, if you consider any in-memory database, that is stored as a key value stored in a string format only, right? But what if you have a different scenario, business logic, where you have to convert it to say map, hash, or sorting, apply the sorting performance, will trigger it, right? You have to write your own logic. But Redis data structure provides all the basic data structure needed for your application logic. Okay, we'll see in the upcoming slides that. And also, if it is in memory, it has the option to have a persistence on DB. You can have a snapshot, create a snapshot of a DB and store it, and whenever required, you can reload in the memory and perform the operation. So it is a bit, not big, but it's negligible time consuming, but it's amazingly fast. So these are the brands using it. So if you explore 4,000 plus brands are using Redis for their different. So you must be aware of these. The Stack Overflow we are using, the Insta, Twitter, list, everything. Okay. What are the features? How is it different from other in-memory database? So these features makes it the better option. Like it's in memory. It's, as I said, extremely fast. You will get the performance in nanoseconds. Okay. It has a master-slave application. If you have a microservices environment, okay, so you can have a Redis client as a slave applied in your particular node or Docker gateway container, or in your own environment on the micro environment. And the master will be synced to all the replicated servers, Redis servers, clients. Okay. Can be used for high volume for most of the programming languages. I heard of 50 plus, but I don't know the 50 plus programming language, but it has client available for that many programming languages. Now time to explore the data structures it has support for. The basic key structure, it has a string, the basic one, bitmap and bitfield are same as a string only, but that are stored in a binary format, ones and zeros. Then we have hashes, list, set, sorted set, Geospatial indexes, that is for lat long, you can store your information in lat long form. For geospatial, hyperlogs, that is log-based database, and the streams which we are going to explore in today's meetup. Okay, let's move to use cases here. You heard of use cases as a caching only, most of you, but it has more over that. You can use it as a, say, for real-time analytics. You can just use hyperlog for that. You can have a real-time ingestion on a streams, notification, content caching, and more. Let's move to the stream overview today. Before that, I want to just understand what is stream. What streaming means. Anyone?
Loading continuously.
Okay.
And like say if we stream something, it is flowing continuously maybe or loading continuously.
Yeah.
So as to like.
So at the broadest level, I visualize it as a conveyor belt where you can take one item, add one item, and if you look at it as like in a reactive sense, like nothing has to be blocking. Like whenever you get an event that ready for consumption, on a particular event you can perform a certain action.
Right. So mostly the streaming part is like the producer and between the producer and consumer, right? The producing is like you produce some content on the fly, and you don't like we have a streaming of say videos or some image processing or media processing. Do you store that content in your storage, or on the fly you get the stream packet or messages and the player or consumer just convert it and show the result? That's how it works, right?
Yeah.
So the Redis stream part is same as that. Let's move. What is data streaming? See, it was introduced in Redis 5.0 in October 18, I think. It was introduced to officially introduced in Redis 5.0. It's primarily append-only data structure. The data structure is like we have a log file. As in when new logs or data gets generated, it gets appended at the end, right? This is how the same way the Redis streams works. Your new data consumed gets appended at the end of your stream. It connects the producer and consumer, and the most you can say best advantage or valuable content Redis stream provides is a consumer group. The consumer group, the concept we're gonna explore is like you can, while producer is producing your content in the same stream, you can have a partition of data, and you can create different groups to consume different parts of your stream. Okay, so if you have say producer creating 1,000 messages per second, so you can create and explore, have a partition in 10 different group of 100 and have a different consumer consuming from different partitions. So this way you can explore that and have a consumer group available in Redis Streams.
Is it similar to topics in Kafka?
You can say that. Yes. Similar to that. So Redis Stream is actually inspired from that, but has moreover the technological benefit. You can explore that in Google, but I will tell you as and when we will explore the Redis Stream.
In Redis, we will be getting the
data structures, right?
But in Kafka, we
streams
only.
Yeah, streams only. So let's see what are the benefits you will have in Redis Streams. See, as we said, the Redis streaming part is the basic concept. You will create lots of volume of data, right? It gets ingested to your system. So Redis Stream will help you with collect that high volume of data at better velocity. Okay. Create the data channel between many producers. As we said, the topic part, we can have a channel that is called as a stream in Redis Streams. Okay. Effectively manage your consumption data between when producer and consumer don't operate that same way. See, we assume assume your producer and consumer operate at same level. You are creating some bunch of data and consumer is consuming that. But in real world, it is not possible. The producer may be at high end, may be producing lots of data at the rate, and consumer might be at lower end. So there is a chance like won't be at same base. So Redis Stream will help you to manage that type of data and will bring you at same level with scaling part of it.
So will this remove the need for the back pressure that is provided?
Yeah, backlog you can have that managed in your consumption part, in consumer groups.
But you're saying using Redis Streams, even if there's a data picture which doesn't support back pressure, we can still use it using the streams itself.
Using streams. Process your data when you are not available. Like we aware of Slack, right? So when you are offline and when you come online, if you are subscribed to particular channel, and then when you log in, you will get all the messages, right? This Redis stream is a use case you can consider for that. Like you create a stream, the producer, you put a messages. Stream is a particular Redis meetup channel on Slack. Okay, so particular consumer, we all are consumer, we'll subscribe to that, we'll consume that messages. Scale your number of consumers, say if producer is producing say 1000 messages per second and consumer is at say 100 messages per second, you can scale that and have applied 10 consumers to it, you can scale it and there is no data loss. And Redis takes care of that, like no same data is consumed by two different consumers. So Redis takes care of that. Transaction like data, as I said, data safety is there and use main memory efficiently. Okay, the point is Redis use Redis Stream. That is the better way optimization of your memory, so you don't need to worry about that. Redis handles that also. Now let's see the representation of streams. As I said, this is the Redis stream part, your append only data log. You have multiple consumers, producers and consumers at different level. See, the part is, as I said, consumer group is the main advantage provided by Redis Stream, as it is the same concept of Kafka, but and also the consumers, you can have different consumers, like you have different microservices available consuming from Redis, performing different operation, providing output or have something available to end user. And consumer group, as I said, can be part of as a channel you create on Slack and different consumers getting your messages from it. And the operation different, like it has commands. We will explore that in upcoming slide. So this is how the representation is. So you can say the producer produces with xset command and consumers are with xread, xrange. You can apply that, say for your use cases. I'm going to explore it. We'll see to it. Let's start with Redis Stream commands first. Okay. We'll see some live commands also. So basically, first start with the part how different commands are there. Like first, add only command. The only command available in Redis Stream is xset. The way you can produce messages to Redis Streams. Okay. The syntax is like xset. You can have a key available. You can different consume and produce in. You can produce in different streams and key value pair. Yeah, it has a key value pair available, and there is no limit to how many messages you are putting in your streams. As I said, it appends directly to your streams. The main advantage it has is it auto-generates your ID for, but you need to identify for particular message, right? Redis Streams, while you add or produce some message to stream, it automatically generates unique ID for you, which will help you to identify message, query on that message, get that message available to different consumers in a consumer group. We will explore that in command level also. The command, the sizes you can limit, like if Slack, the free version of Slack has, say, you can have 1 million messages in your group, right? So the limit you can apply, if you are producing some message to your stream, you can control that with maxlength also. Like I want to only produce 1000 messages in the stream. If it goes beyond that, the older messages automatically get truncated. Okay, let's move to command first.
Older messages get truncated.
Yeah, you can apply that.
But it will be stored somewhere so that I can get that truncated message.
You can.
Or else it should not accept data, something that kind of stuff.
Sorry,
If you have set max length, then it should not.
that is a limit you are applying to this thing. So if you skip that part, there is no loss of data.
So what I was saying is, let's suppose it is truncating the data once the max length has been reached, right? And it will start appending the data.
Yeah, it will.
The other way, you can stop that addition of data in the same stream once max length has reached.
Yeah, you can apply that logic and get the explain, and you can
Instead of
have
data.
that part say
Instead of
create
data, because it might be some kind of
a different stream. You can append in a different stream. That we have to manage with code.
Is there a default max length?
No, there is no limit.
Okay. So by default it will be unlimited.
I mean, this depends on your
Memory. Okay, let's create a new tab. Is it visible?
Yeah.
I think you should increase the font.
Yeah. Better?
People have that.
Is it better now?
Yeah.
Okay.
check it whether it's permanent or not. Maybe you have a wiki for which case that will be easy.
Okay. We are starting with producing commands. So I'm just creating a representation here. Please mind my handwriting. Here's a consumer. Here we have a producer. This is the stream part here. And consumer is consuming it from. Okay. So while producing, you are adding a new message to your stream that is held with xadd command. So we are going to explore that now. Xadd. Sorry. It has given you the syntax. It has xadd. You have to first provide the key. It is a mandate part. In which stream you want to add that message. If it is not created, it will create it for you. Then the ID. ID is the unique message you have to provide, and that comes in an incremental way. Incremental way means if you have created your message at particular say time, say xadd my stream, it won't be visible, I think. Say I'm creating a say meetup as a today's stream I want to create. It has, if you provide a star here, it will generate it for you. The format is, I will give you the name, say so it has added a new message to meetup stream. See, you're seeing the format here, right? This is the ID generated by Redis. If we provide a star here, it will generate it for you. If you are interested in creating your own way of ID to identify your message, you can give it, but that should be in incremental way. Incremental is it? If you observe, that is the epoch timestamp. Yeah, it gets generated in milliseconds part, and there is a -0. -0 is a sequence maintained by Redis. See, in particular millisecond, you can have hundreds or thousands of messages get generated in high volume of data.
Yes.
So Redis, as I said, it's a append-only data structure. All the messages get added to it, and it maintains the sequence of it. So the sequence get appended for particular timestamp gets added to -0. We can see that in multi-command also. So if I provide, say, It won't allow me. Smaller. Obviously. Okay, if I create a new stream, say meetup 1, and if I provide, say as I said 1, 2, this is a for new stream. I have created meetup 1, and the starting message has a sequence or ID at 12. It will create it. If I give say 12 or say 11, it won't allow me. But if I provide it as a 12-1, it will help me. If I give say 13 here, this way we can have an incremental wave. So as we have a meetup as a stream now and messages have been added to it, now let's see how the sequence is maintained here.
For the same number, will it override also?
No.
Actually, because I think with this number, the partitioning and the consumer groups, we can segregate the loads accordingly with the partitioning IDs.
Not the partitioning.
With these IDs, I think that it will be segregated. We can distribute the loads according to the IDs. Suppose I am having the same value, same ID repeatedly, and I am publishing that. And with that ID, I am segregating the loads on different Redis clusters. So how I will be providing that same ID so that that request goes to the same already maintained cluster. Suppose the IDA or whenever I am putting the IDA, the always goes to the Redis 1 cluster. If I am partitioning from ID A2, the Redis will go to the Redis 2 cluster. So how we are going to take decisions on that unique IDs?
See, you have to provide the range in that case.
So because ranges can exceed and according to our different, suppose we are extending a cluster and ranges are also increasing. So my IDs, the consistent hashing, whatever will be going to a particular cluster, will be changing. So on that basis, now my request 1 goes to the request 1 server of Redis cluster, it will go to the request 2 of the Redis cluster. That we need to take a decision.
So if you're trying to create groups based on ID, I mean, as you mentioned yourself, it's a unique ID, and you can't publish multiple messages on the same ID. So you actually can't differentiate based on ID because, and when you say consumer groups listen to the same streams, and Redis decides in multiple fashions. It's either failover or round robin. It publishes that particular message to all of those consumers. Okay. Now, I mean, that's a very specific use case. We can come back to it later. But in short, ID is not the actual parameter where we should partition.
Yeah.
There should be
The
some
consumer
other-
group part is different. The way you actually consider it.
I think that was a very specific.
Yeah, but solution could be sorted out, but this is not done.
Okay. So if we want to check it how it actually maintains is, we can say multi. It got queued. Then again I'm adding say different command, different value here. So it actually added the message with same timestamp but different sequence. Okay, this way actually it has maintained each and every message and identified uniquely by this ID.
May I know why you use that multi?
Multi is like you want to perform same transaction at a single go.
Same transaction?
Yeah, you want to see if you want to commit the same message to different databases.
Okay.
So how you create a transaction and then commit it, right?
Okay.
So in a Redis, you have to create a multi, perform different commands and execute that. So it will perform in a one go.
Okay.
Okay. This way we have added a new message to stream. Now I want to consume that. Sorry for that. maybe we can, after completion of this basic intro, we can continue all the commands. So just after you add, you want to iterate over the data. I have added different values to this stream. I want to consume that now. See, there are two ways. You can either go with xread, or if you want to perform on operation on say range, you can have a xrange, or in reversal order, you can have xrev range. So ranging is like you want to get the past data, not the newly generated data. You can go with xrange or xrev range. It returns time-specific data. Like you have a use case, right? You want to perform some query on your say images you have stored. You want to get it like on particular day which image was stored. You can directly query that in xrange or xrev range. It has a special IDs like minus and plus. We are not sure which particular unique ID was added for particular message. So, and you want to query from minimum possible value from the stream. So you can directly provide minus and plus, which will give you the minimum possible and maximum possible message from streamer. It reads over the past data. You can't query the newest data. If you want, you can go with xread. The results are inclusive IDs. Here the disadvantage you say, or the way it is programmed is, when you query, you provide the start and end key to your syntax. It results your message inclusive of the message you have provided. Like you have, say, perform the pagination on your stream part. So it will result you say from 0 to 10. So you have to provide this plus the next sequence here, say 11. So if you want to again iterate to next page, you have to programmatically provide 11 to count maybe 10 or 20. So this is inclusive of IDs passed. Next we have a
Vishal, does this xrange actually consume the data, or it's just read? It does a read.
It's a read.
So data will still be available within
It
this.
will be available at any moment of time. It's like you are querying a data in a database. See, Exchange pop-ups asks you for a stream, start and end. If you are known for IDs, else you can go for minus and plus. Count is like you want to limit the query data. Like I want 10 rows from stream only. Okay. Xread, it's the same way you can consume a data from stream is xread, but you can get it the latest data from, if you want to say query the latest data, like we provide tel minus f on a command prompt. So whenever Tomcat appends in new logs, you directly fetch it. So you can directly, the same way you can query your stream with xread, providing a $sign and 0 for query from the beginning part. Read data from multiple stream also you can have it. It will actually give you stream specific data. So if you provide different queries streams, it will give you the stream part and the messages available in particular stream. Can block. The main advantage here is it can block. Blocking is like you want to perform asynchronous operation on stream. Like your producer is slower than your consumer. So consumer has to wait for new message, keep on checking on it. Okay. But when say you want to perform asynchronous at particular say 60 seconds of interval you want to consume it, you can block your xread command with block as an attribute available and query your stream part. So that is a asynchronous way of communication in this case. This is available only in xread, not with the xrange and xrev range. And the advantage here is it is exclusive of your IDs passed. Like you have passed 0 to 10. In the next sequence, it will give you, you don't need to provide the 10 plus 1 calculation. It will automatically have a next available for you. Let's see at command level. See, have a xread. Count is your optional part. Okay, so streams I am providing. say meetup. See, if you want to perform, say from beginning, we had these commands available, right? In the meetup one, I have added latest one. Okay. And if you want to say apply count here, it will give you the two available messages from it. It will give you the from beginning, not the last one. Okay. And now let's query on range basis. It has range. Key is my meetup. Start is say minus from beginning. Give me all this way. I'm not sure about the beginning, start and end of ID, so I have provided minimum possible and the maximum possible. It has given me all the available data element. Again, you can have a count available. Say you want to perform some pagination, give it a count. If I want to say a query, say from only for Vishal and APC, have to provide that an ID. Just so assume that you have bunch of data available. Programmatically, you have to maintain the last key ID. You have got it from the last result. You have to again query and for next page, next data part of data, provide that particular thing up to particular say ID you want to query, and again the count you have to provide again. If you want to go for reversal. You have to I'm not going for see ABC was the last. I got data in a reversal way.
Can you just tell me one thing that you said that in X range, the latest data is not available.
Latest as in on the go you can't actually query.
Okay.
You have available.
Okay. So whatever data which we have added on the go.
Or it gets added to it and your consumer is waiting for it.
Okay.
So you can't go that. You have to query it from say start only.
Okay.
If you want to check, then you can use monitor, Redis monitor, and then you can check for that particular key or something on real-time basis if you
On
want.
real-time basis. Okay. Cool.
Any query in these commands, exchange and okay.
One question.
Hmm.
Is there a regex option available where I don't know the hyphen ID? Okay, I know the timestamp. So basically, let's say I want to see last 30 minutes. So I would come up with a timestamp, but I don't know the hyphen ID. So is there a regex available?
Hi, you can actually skip the sequence. You want to skip the sequence?
Yeah.
So you can directly skip the sequence here and provide this timestamp only. Like we want to query last particular 1 hour of data,
Correct.
and you don't know the sequence. So Redis will give you from beginning.
But pertaining to that range only, right?
So time you have to convert that particular time to timestamp format and give it a query. Any other doubt in this? Let's move the important part now. See this. the consumer group part. Let's first understand how the consumer group works in Redis streams. See, Redis, as in when the producer produces, it actually maintains your unlisted data in this thing. Here, streaming part is you have a single or multiple producers. You have created a consumer group here, say Meetup. Meetup is a consumer group for me. Okay, it will fetch it from stream, but that part here I want to understand is it can have different consumers in it. Okay, like I want to have a say example I'm different again is I'm producing say 500 images per second. But my consumer part is capable of 100 images per hour. That is not the right way. Like in seconds, it is creating huge amount of data, right, for me. I want to maintain that. So I can scale the consumer part here, like the image processor. I have created the image processor group here. And I can have different consumers or multimedia processors, you can say, part of consumer group as a consumers. C1, C2, C3. These are the consumer group, consumers part of this particular consumer group. So this is a consumer group. Actually what Redis does is, it actually creates internally the unlisted type of data, which is not consumed by any of the consumer in consumer part. And different apps, obviously different apps will consume your data. So they get assigned to different consumers in your consumer group. And when particular consumer is partitioning this, the partitioning comes here is particular consumer will have this part of data only available. The second will have this part of data available. When you consume this part, actually you can say that Redis won't allow the same part of data bit available to different consumers. Redis takes care of that in a streaming part.
Redis itself decides which part to be consumed by which.
No, you have to query them.
Okay, so I have to tell them.
Vishen,
Yeah.
in the case of Slack that we had taken earlier, so all the apps will be end users. So all of them should be receiving all the messages from that particular channel.
See, Slack is not, in that case, Slack you can say is a stream, and you are the consumer from this game. Consumer group is different from the Slack. Slack is like, I can tell you, you create a new stream, you create a new channel in this, say Meetup channel. This is the basic form actually. The producer is any of the multiple producer is like we all are putting a new message in a group, and we have different consumer in this case. There is no consumer group. You are directly querying from your stream. The new channel is nothing but a stream here. The case is multiple producers are producing in a single channel. Multiple consumers are consuming from same channel. The consumer group part is different from this. The example you can say. What is there any doubt in this?
So we have to make many consumers in that way.
You can create a number of consumers are like we are reading the message.
But if we want the whole queue to be consumed by many people.
Yeah, same way. So there is no limit to how many messages are being read by any of the consumers. In consumer group, there is a limit like particular partition of data is dedicated to particular consumer. In Slack, the stream is available to all the consumers and producers. we all are putting a message to stream, we all are reading it from it. So it's end-to-end, many-to-many communication in a stream. Manage consumer groups. Let's see how that command level we can create a consumer group available to consumers. See, this X group command is the way you can create, destroy, delete a consumer from your group and maintain the last ID delivered message. And it is specific for consumer groups only, and has the option if particular stream available is not available, you can provide the MK stream. It will create a new stream for you. If you have created this way, you can read your data like from X-read group. We have seen the X-read, right? To consume a data from stream. But X-read group is to consume it from consumer group. Here what you have to provide is group name, from which group you want to read it. And basically this would be queried from different tabs. Okay. The count you want to query for and block millisecond. Again, the X-read has a sync operation. Same way you can block operation for particular time period in milliseconds. No ACK. See, operation like you have consumed that message. Stream should be acknowledged. Okay. Else it would be available as a non-consumed part or an unlisted part. If it is consumed, it won't be available to any of particular consumer to it. And again, no ACK is like particular message doesn't need to be acknowledged. It is consumed, that's it.
We should have a question here. So when you're saying acknowledgement, so does it can perform operations after the acknowledgement in the stream? Maybe I want to reduce the data, archive it somewhere, or it is just for the sake of acknowledgement that it doesn't acknowledge?
Acknowledge is like the data, as I said in the previous slide, it's available in unlisted form. It's pending for to be consumed by different consumers.
Mm-hmm.
If you acknowledge, no other consumer can query it. Like there is a scenario I will tell you.
This is more like you're talking that basically this has to be.
Yeah, this is dedicated to me only.
Mm-hmm.
So I have consumed that. I will acknowledge to particular message. So it won't be available in say, no other app or consumer can claim that particular message. This is how the acknowledge part works.
Okay.
See, this is acknowledge, like I want to acknowledge particular stream in a particular group, this particular message I have consumed it. The X-read, as I said, again, you can have the blocking operation in it. And the most advantageous part here is like if particular consumer fails to consume that particular message, other consumer can claim the particular message and consume that particular message, right? If I was say consumer 1 consuming this particular data, okay, so this is dedicated for C1, but it has read this message but have not acknowledged yet. And C2 and C3 are idle, they are waiting for new messages, and some particular system says I'm not able to get message or any data available from C1. So what you can do is you can ask C2 to look for the pending messages for this consumer and claim that. This is the advantageous way.
Is there a configuration to do this?
There is a command you can do that. This is like expending to look for the pending commands or pending messages to be consumed from particular say, consumer and claim. If you want to claim that message, you can do that.
What is this PEL?
Sorry?
What is this PEL?
This is pending entry list. This one, unconsumed list. It is waiting to be acknowledged, you can say. These are the basic small commands. Like if you want to say, see the length of a stream, you can directly query it with xlen. want to delete this thing. Yeah, one more important point. You cannot modify stream data. It is, unimmutable. You can only create a or delete it. Okay. Trim, again, we have the option of while you accept, you can provide max length, right? And you have an additional command to trim it. You want to say cap particular stream to be of length up to say 1000 messages, you can trim this externally. And acknowledge, as I said, if particular consumer has consumed a message, you can that can acknowledge particular ID message. Let's see at command level now. Let's create a group now first. Let's group. Redis. Is visible? Create image groups. Have a stream, my stream. Okay, my stream. Where to different command. Create key simulator or image group. This command has created a new group, image group in particular stream meter. And dollar is like deliver new messages available to the consumers. Dollar sign says that. Okay, we have created that. Now I want to read that message. I need to maintain the field. Yes. And that was image group. Consumer is when you provide a consumer name here, it will automatically create a new consumer for you. This is basically the command will be queried from particular app or consumer apps, we can say. So I want to say create a consumer one here. Count is again, this is optional part. Want to see this. Okay, acknowledge streams key and ID. Stream I have to provide, say stream name was sorry.
Streams
Yeah.
is
It's empty because I have already don't have any message to consume it from. From now onwards, when I put a new message in it, I will get that. Say, sorry, meetup consumer one. It has different. Sorry, I'm yeah, I've added this. Actually, I've added a new message in a different window.
Can you increase the font size?
Yeah, I'm trying to that. See, in a different window, I have added a new message to meetup group. I named XYZ something, and consumer crew. I've got that message. X-Ray group. Okay, so this way you can have a newly message available. As I provided a $sign in while creating a group. So whenever new message gets added to your stream, you can directly query with read group, X-Read group, sir. And the difference part is like whenever you create a new or provide a new name here, I have consumer one here, consumer two. It will create a new consumer in your consumer group, like C2 is we have. It doesn't have anything. Sorry. It's nil because that particular message was consumed by consumer one. Now, say I want to perform this particular operation, like different consumer querying from particular partition of data. We can do that with this thing. Say I have these particular commands available here. Say meetup star sequence as a one. I'm just using the random number, random queries. I'm adding sequence 2 here again, sequence 3, sequence 4, sequence 5. I've added 5 messages to our stream Now I want to query it, like consumer would want to have query on particular message in a stream. So I want to have a consumer one be available with these two messages, consumer two with this. So, next read. I'm getting this. Count as 2. Syntax I have to verify. Locking streams key. Okay. Yeah. So consumer 1 has acquired 2 messages from stream, the sequence 1 and sequence 2. Now consumer 1 is done and want to do it for consumer 2 also. So it will have it, as I said, the same messages won't be available to different consumer if consumed by one message. Consumer. So consumer 2 has got acquired 2 messages 3 and 4. Yeah.
Yeah, just one question. Can I implement a priority messaging in this case?
It is a
sequence.
sequence.
That's
You can have provide IDs also. So ID is like you want to have
no.
ID available of a message produced to this thing.
Okay, ID is different, but
ID is this thing.
okay. So I have 3 consumers.
Hmm.
Three consumers in a group, right?
Hmm.
I have this one stream, and in this case, say I am Walmart and I have multiple vendors, right? And I have a large high priority order, which is part of the stream. And I want one vendor which is basically has no resources, it's high priority order. So
Mhm.
I want that vendor to receive it immediately, although it's part of the stream. So will that be, can I implement priority queue?
See, for particular order you said
So yeah, depending
you can
on
have, you can have that.
you can have that.
Like you must be
So
having.
sequence 1, 2,
Hmm.
sequence 1 and 2 are normal order. Then I have a high priority order. 3, 4 and 5 is normal.
Hmm.
6 is.
Yeah, you can provide that.
But only consumer 1 should get 3 and 6.
Yes, you have to provide
Immediately.
message like you have created an order. It must be having some particular ID. Correct. So when you consume that, say particular consumer has the highest or better say processing level, you want that order to be available to that consumer, right?
No, I'm saying, can I jump the queue? So can my high priority consumer get 3 and 6 immediately, or do I need to consume 1, 2, and
No,
3?
that would be independent of the way consumer has. You want to acquire particular message to be consumed for particular partition to be available to consumer, you can do that.
No, but
Or the priority or speed level you are asking
no,
about.
no, I'm saying does 1 and 2 need to be consumed before 3 is consumed, 4 and 5 need to be consumed before 6 is consumed. What is
That is based on the consumer level, how the consumers are consuming it from the and see, I got your question like these 2 messages should be available and this should not be available and this should be available, right?
no? I'm saying Yeah, I mean, can I go to the third one with consumer, high priority consumer?
You can, but you have to again query it with different.
Very different.
Yeah, as we provide the range in this, if you
So
want,
sequence does not matter.
sequence doesn't matter. It is independent of consumers.
Independent of.
Yeah, it is independent.
So my low priority consumers can wait. I mean, if their resources are low, I mean, asynchronously they can.
They are asynchronous. As I said, the consumer one has acquired sequence 1 and 2. Consumer 2 has acquired sequence 3 and 4. Let's see if consumer 1 can again see what it has 5 only available. So 3 and 4 is actually consumed by sequence 2, consumer 2 only. See, now let's acknowledge those messages. Like I have consumed those messages, I have processed that messages. So those two messages consumed by consumer 1 should not be available to some other consumer. So I need to acknowledge that ID. Group is IMG group. Sorry.
Sorry to interrupt. We have to know. Thank you so much.
Yes.
So I have acknowledged that. Like that message is consumed, it won't be available again. But consumer 2 has 3 and 4, it has not acknowledged yet. Okay. So if we check it like with expanding, my key is meetup. Group is image group. Start and end, I'm not sure, so I will provide this thing. Consumer is consumer 2. Sorry. Expanded has
I think it will provide count also.
come there, I'm trying that. Stream. It's empty for consumer 2. Sorry. My mistake. It is available, sorry. The message one and these messages are available for consumer 2 which are not yet acknowledged. Okay. So what it gives you is consumer 2 is having these messages waiting since this thing, and this is the count it gives you. So consider consumer 1 is consumed and it is idle. Consumer 2 has read these messages but not yet processed it or not yet acknowledged it. But there is a condition that consumer 2 has failed it and your application wants that data. So what you can do is consumer 1, programmatically you can look out for consumer 1 is idle, that can claim message available in C2 and that can be consumed by C1 also. How you can do that? Using exclaim. You want to claim those messages. Key is my meetup, Group is image group. Consumer is minimum idle time and 0. ID, I want to add this thing. I've got sequence 3, which was for C2. I want to have next one also. You can provide multiple IDs at a time. I've just shown you this. I want this message also. Got 4. Now if I check out for like this way, in expanding it was showing those 2 messages available. Now let's come see if it has any. It has nothing. Count. Now I have claimed those messages in consumer 2. These were available since these things, these ideal time. Now I'll have to acknowledge those messages at that level, next level. That I have consumed that, claimed that. The same way we have acknowledged it, right? Accept, meetup, image group, those 2 messages were consumed by consumer 1. Now we have, when we query for sequence 1, consumer 1, sorry. That was in, yeah. It has nil, nothing. It has nothing to be, it has consumed those 2 messages available that will acknowledge actually. The stream is empty now. If I want to say, check for consumer 2, it has nothing pending to be consumed.
So basically, see, consumer 1 deletes it or acknowledges it.
Acknowledge, has to acknowledge.
It's the same, right? If consumer 1 deletes some part of the message,
Deleting is something different.
either delete or acknowledge.
Acknowledge is like, yeah.
It's
Yeah,
one and the same for the stream.
No, acknowledge and delete is not same.
Delete is like it won't be available to be consumed for anyone.
So you
Achha.
cannot read it. Acknowledgement, it's
You are
read
deleting from
once.
stream.
Basically, we are telling the queue that yes, we have consumed
Consumed
that
that.
thing and please just remove it.
So in the beginning, if you remember, there was an
And it stayed or pending PEL or the pending entry list.
Okay.
So it gets actually removed from pending entry list.
it is present in the stream, but it is not resent again.
So another consumer group can consume it.
If it is an
If it is PEL, no one has acknowledged about that. So as I said, the C1 has consumed from the C2, like it queried for pending list and has acknowledged that. So we covered these command also. Now let's see the use cases available. Now everyone understood about how it works, how you can query, how you can actually have created a consumer group and different consumers query different part of data. Okay, any doubt in that? Let's see the live use cases now. Scaling out consumers. As I have initially said, you have producer at say creating or producing different images at 500 images per second. You are putting in a stream, but consumer is slow. It is capable of processing only 100 images or messages per second. But you want to keep it at same pace. You can scale out with multiple consumers. Like you can, as I said, multiple consumers in Slack. We have multiple consumers. Same way we can scale those particular application and consume it from Redis Stream. Like this particular range will be consumed by image processor 1. Then from like pagination we had, the 11 to 20 will be consumed by image processor 2, so on. So you can scale that with Xrange, Xrev range, you can query that. Next, we will see how you can use Redis Stream at IoT or microservices level. See, in a real world distributed system, you have IoT or ARM based devices available producing, or different sensors available producing lot of volume of data, and gets actually appended to a system. System actually, the ML and ER perform some operation, give it to analytics system, and consumers consume that system. We see this is the easiest system, but there is a huge volume of data available. Okay, so that is easily maintainable by Redis Stream. Like different devices, IoT devices, you can say it is available in car. Your speedometer devices are producing some device, or on the internet, or some apps are producing. Say, consider there's a toll naka available. There is option to be read from, say, e-tag is there, right? So yeah, faster way. You can have an app also, or a particular person sitting inside a cabin also producing some tickets and performing some transaction. So consider that way we have different way of generating that data. So you have a Redis system available. It is the smallest one. It is available in ARM and IoT devices nowadays also. So that can actually push data to cloud system, Acced. The same way we are a producer here, producing data in Acced in a stream on your Redis server. On Redis server, you have, say, you have data available in a stream, and your application is a microservices level application. Different services query from Redis server, Xraid or Xrange, or anyway, it is consuming data from Redis server, can push it to, say, your data storage, and can be provided to analytics server, and or you have data available to as API available to third-party system. So this way you can, this is a scenario like how you can produce some stream of data or images, or streaming like videos providing. You have a, say, Twitter app, you are live streaming, we are live streaming now. Can be from system, from a mobile also. Data gets added to YouTube server and gets consumed by different apps, different microservices. Again, the next is microservices. As I said, the app or browser is putting data in different services. This is like e-commerce example here. The consumer or buyer is booking up some product. Okay, there is account service, there is order and inventory. Your order is maintained, and obviously you have to maintain. If order is purchased or particular product is purchased, you have to, for that particular transaction, you have to maintain the inventory also, right? Like you have 10 products available. The order has 2 products in the cart. So in inventory should be 8 products left in it. So this way you can maintain that data added on a Redis server. So different microservices will push it from their client level, and server will maintain different operation or transaction available in it. There is one more consumer group, like you have different analytics service, messaging service, or data backup service consuming from stream. So Redis Stream is not limited to particular scenarios. You can have available in different scenarios, like you can have it as IoT, as I said, user activity tracking. Nowadays, e-commerce site, that when you buy some product, browse to particular product, you will see the list of other items seen or purchased by other buyers. How is that done? Like when you browse into Amazon or Flipkart, it actually adds that particular product to a queue, accept. When you browse and look for some other product also, so if you have bought some self-help book or a particular data structure book, you will see the suggestion, right? So people browse through different products, and that data gets added to big backend system with Excel. Okay, so this way actually ML or AI system suggests to other people also, like particular buyer was also interested in this particular product also. So this is a user activity tracking, you can say, or a sensor we are getting inside an office. Okay, via sensor. So sensor can producing some data, how you are roaming around in a premises, that can be tracked. Machine learning, as I said, fintech, different financial level transaction get updated and can be consumed by AI systems. Log collection is the basic system, as we said. So these are the different scenarios. So fast data ingestion systems where Redis Stream is most advantageous available from Redis. So these were the use cases. Any doubt in this part? Actually, yeah.
There's no doubt as actually the use case that you listed in the entire discussion were around streams. So you actually talked about an extra feature that many of us are not aware. We primarily use Redis as a cache, as a shared memory between two servers, maybe microservices we use for message passing. So when you compare this for streaming, the direct comparison between this and a messaging queue or a Kafka comes into the picture. So do we have a comparison sheet somewhere that we can say what are the strengths and weaknesses? Because you are asking people to switch to this as compared to, because in the architecture, Redis is always there and the queues are always there.
Yeah.
If you take fintech, it's a norm. It's everywhere. Yeah. So are you asking people to shift to this for their entire solution? For caching as well as streaming?
See, if you are interested to explore and see, Kafka is from long time. I think it's been more than 4 or 5 years. If you have already system available and you are using a Redis, which is a simpler way to configure it, right? You don't need a zookeeper like we had in Kafka.
Redis is much easier to work with.
Yeah, so there is no configuration management headache for you. There's no different app managing your messaging queue. Like Zookeeper keeps on updating your offset and these things. Keep on configuration part, right? Redis is also available for your system. There is a simplest way to query with different data structures, and you don't need another module to install streams. If you have a Redis install, you can directly have your data get available in your memory. So there is the easiest and simplest way you can achieve with Redis.
Ease of integration with the existing system with Redis, you have the advantage. Are there any payload limitations to what the stream can have, each of these messages?
That benchmark is not available for...
Because Kafka has a certain limitation for a large volume of payload.
And there is no limit in this. The limitation is how much memory you have.
That is, you're talking about the entire stream.
Infra, yeah.
I'm not talking about the entire stream, I'm talking about the individual payload, individual message.
Payload has no limit. What is the, may I know the limit available in Kafka?
I have not checked. In our team, they had issues because they were using for liquidity. So it was a system where there was a large structure of transaction passing. There was sweep instructions being put. Like from in banking, they do sweeps and liquidity. So that was a very, very complex structure. I did not get the number, but it was large enough for Kafka to break, for it not to work. That is where this was introduced for caching. So Redis could handle that payload, but Kafka could not for a message. So that was the advantage. But in looking at, even if Redis has a limitation in the terms of payload.
So Redis internally has the limit of 512 MB. Okay.
For each message.
Yeah.
For each message.
Yeah.
Okay, 512, that is large enough.
That is, yeah.
So I'm not sure if it's still applicable here, but otherwise you can have a 512 MB key, you can have 512 MB value. And internally, as I mentioned, it's ultimately it's the list which is being maintained in the queue. So internally, when you say streams, it's linked list which is being used to maintain the queues. Okay. So I'm assuming same features are available here also, but I can't actually provide the source for it, but I'm pretty sure it would be fine.
Okay. Another thing I wanted to ask is you're showing images as an example. So
use cases?
In that use case, you showed images for the...
Which one?
Yeah, this one.
This one?
Yeah, in that use case, you showed images being transferred, images being read. So you're using bitmap as a data type for this?
You can use bitmap or you can have base64 as a string. That is a string only.
String, how can you use for this?
String as a storage. So if you convert a image to base64, that is a string. Or you can have binary form as a blob. Yeah, blob. Yeah, that is a like bitmap, bit fields are available.
We use primarily strings. So that is
string. That's why I said the base64 is a.
Yeah. So feeding data right to the topic of the producers. I mean, that's basically why we go for Redis is basically volume fast data. So that is maintained, right? I mean,
Yeah.
The internal architecture is what Redis provides.
See,
what is the amount? How much can you process in a second? You mentioned it's an APS, and it has to go 3-4, right? So when you have
see,
bombing, so say you have stock market, right? High frequency trading, millions of transactions. Can I use Redis?
see, there is a performance optimized in it. Like you have to query when you query it, when you are
I'm
using
asking
Redis
is how-
Stream,
No, I'm not asking about client. I'm talking about the
Putting it-
list.
The
How fast
throughput.
can it consume?
Yeah, so do you have any numbers on throughput?
throughput. No, but if the producer is of OF1 only. So how many messages you are producing? OF1. Complexity if you are talking about. But when you are querying it, as I was talking about, it will be O of n based on how you query it. There is an optimized way you can perform operation like maxlen and this thing. There is a tilde operator you can provide in while query. What it does is like it uses a macro node in Redis tree. So particular node is has some particular limitation. You say maxlen I'm providing. There was a command maxlen, right? When you're producing a message in your stream, okay, there is no difference if you provide say 1 lakh message and tens of more or less, right? Not less. It won't matter if you have 1 lakh and 10 messages. Would it matter?
No, I'm asking.
I'm producing some messages.
Correct.
There is a limit you are saying.
Yeah, I want to know that limit.
Limit. There is no limit to how you produce, but optimized way of producing some messages in a limit. You can do it with max length, providing a tilde operator. Yeah. So what it will do is it will actually maintain a Redis tree. Actually, traversal will be less, and you will get the better optimized way of
Like
adding a
file.
data. Yeah.
Like you're sending a file from.
Yeah.
Yeah, I was talking about.
So there is no traversal in the memory actually. You can say.
Yeah, I get what you're saying.
So just to add to him, and since you mentioned share market, right? So I'm not sure if you know this, but ShareKhan coded all these. They actually use Redis Stream for their APIs, the ticking data. You mean every second they have data value. The APIs which they provide for the brokers, the agents, is through Redis Streams.
Yeah,
They are actually using it. So
that's the probable use case. I was talking about more about
Optimization.
because you mentioned fast data, right?
Yeah.
So exact numbers I'm not sure, but it would be available.
One question I have related to this, what you're saying is that can you open a WebSocket on top of this and it can be, so the implementation of I was thinking about as a consumer, if I want to show the stock market information on the site, I would typically open a WebSocket and do this, right? And that would give me live updates of
You can have a producer and consumer subtype.
Yeah, but I mean, obviously,
If you
you need
are-
a client for that, your language specific client. And
But for a web view, I would need a WebSocket to connect to this.
For web view,
Part of the language that you are using.
yeah.
yeah, that will be language specific. And this is CLI based applications which are showing.
Correct.
So you can, if you have created a Java application, so you can connect with Redis and have a
Yes.
X-ray available here.
So that latest client.
Yeah, it's supposed.
I was working for ShareKhan and for our Google applications, we were using WebSockets.
Correct. So it's anyway used.
So it's like API consuming the message from a stream, and WebSocket would actually notify to
Right.
consumer.
And a REST API would not be a good use case for this because you're not using live stream. So it is definitely sockets, some sort of sockets, if not
HTTP you can actually, there is no denial on this.
But it's not, it's stateless, right? So you cannot,
Every time, yes.
polling or something else. Okay.
It's like should be available on the fly.
Yeah.
When new message arrives, WebSocket is a better option than this.
You're connected
Get-
by rituals.
yeah, latency.
Okay, any other doubt? Yes.
Replication, does it replicate on the same?
Yeah. There is actually a server and replication is on sync.
Connection tooling.
Tooling is, it's up to on client how it is connected to server. So that was about today's Redis Stream topic. So there is an explore. You can have a
So you mentioned just one last thing.
yeah.
So you mentioned producers can create a transaction and put it right. What about consumers? Can they remove the transaction? Can they remove the transaction?
So that you have to implement on the. You have to implement that at your client or a code level.
For example, you need to provide a gateway where he can just upload. Similarly, just when he uploads, he should have a provenance of getting those again pulled out from that. So it's all about the gateway.
You have to acknowledge, right?
Yeah.
You have to acknowledge. So can I acknowledge a bunch of
You have IDs available. You can actually perform in a pipeline also, like hundreds of in a particular machine. Batch processing, you can do that. You have to maintain those IDs actually.
Yeah, so in a transaction form, like maybe read from Redis and acknowledge that, go to a database, do some transactions, so they're complete transactions.
Yeah.
A banking organization typically use this.
So I can use pipeline for consumers as well.
Consumer is like you are performing operation on server only.
But
You,
I can use pipeline.
pipelining is what you have used that pipelining.
We use it for ingest.
Ingest.
I'm talking about
Consumer is nothing but you are performing some operation. You are hitting some command, right?
yeah, okay.
And so you can do it at any level.
With the IDs. There's no limit to the number of IDs.
In your scripting,
Yeah.
if you want to do some batch kind of stuff, then you
Performance wise, it is optimized way to.
because it will directly expose means given performance of 10x to from 1x to 10x in batch case in your scripting.
Okay, so we have courses available on Redis. So if you are interested to learn, say, different for JavaScript, Java, Redis is available courses. Or say Redis Streams, we have Redis Search also, right?
Yes.
Yeah, so for data structures, they are providing a free courses available and certification available for developers. So these are available. This would be how you can say the certificate would look like if you complete and score 65%, you will be eligible for certification also. So you can learn free and it is provided for Redis expert only. So go and check out on university.redislabs.com. So any other question for now?
Yeah, you mentioned that machine learning use case.
Yeah.
Can you elaborate?
I'm not good at ML, but you can say that, yeah. King at ML level is like, what ML does is, yeah.
So ultimately, what machine learning needs is a huge data.
Yeah.
And
that's what
for IoT, that if you have the data stored, so you can just pass it, time batch process, and it can come up with predictions or
What ML
whatever,
does is just
recommendation,
it
right?
needs a data pattern to identify some pattern, right? It needs data
So 512 MB is the
for a particular message per message. So if you have millions of messages, there is no limit you can say.
yeah.
So ML is like again you're getting some data from different sources, and the ML system will actually optimize it accordingly. The way you want to have our business logic available, get it from data, learn it, and perform ETL on it, and get it available to consumers.
Vishal, one more thing I want to add. You said it cannot be deleted or modified. The record cannot be modified. So it is all add and delete, right? So this is typically like an event store, like event sourcing.
Event driven.
Yeah. So this is event sourcing. So you can just query the data. So this can be used as a central event store. And then again compares same with Kafka.
Any other question?
So just one, sorry.
Yeah, sure.
This Redis, can I mean, I don't know the